Good morning, students. Rise and shine. Actually, today we're going to talk about ice and grind. Today we're talking about glaciers. First, where do glaciers happen? Well, for glaciers to happen, you have to have a lot of snow that's fallen out of the sky and piled up layer after layer after layer, and it has to stay cold enough that that snow that falls down that's piling up is not melting from season to season. So it has to be somewhere either in the North Pole or the South Pole, or in a very high altitude that is staying cold year round. As these layers of snow pile up, they pile up in particles like these marshmallows. Imagine these marshmallows as particles of snow, but as those layers get thicker and thicker, they get compressed and compressed and compressed. So the snow flakes eventually become ice crystals that are compacted, and the glacier becomes one large mass of ice. But because it is still made out of particles, frozen ice particles, those particles have a tendency to move a little bit independently of each other. So while a glacier seems a little bit like a giant ice cube, parts of it still move as independently. So we can think of it like a river of ice that moves very slowly. So think of your glacier like a stack of playing cards. This is the stack of playing cards, but as it's tipped slightly downhill, the part that's moving the fastest is actually the middle layer. The top layer is not moving quite so fast. The middle layer is pressed down, but it's sliding. It's got all the force of the mass of what's pressing down on it that's pushing it and moving it in this direction. So the glacier is moving a little bit like this. Now, of course, along the bottom, you have another phenomenon happen. That force of the mass pushing down is actually creating enough pressure to melt the ice. So we're going to do an experiment where we make a glacier out of a block of ice in my freezer. Next morning, this is what we came up with. You can see that some of that green food coloring traveled through the rest of the glacier, but you can tell most of that material that was in the bottom is still at the bottom. All of this is the stuff that's from the landscape. This is the rocks and soil that were actually picked up by the glacier. Now, as a glacier is melting and sliding, it's actually picking up sand and gravel and chunks of rock off of the landscape, and they call that plucking, when it picks up something. Because this layer here is doing a continual cycle of melting and refreezing, melting and refreezing, melting and refreezing. It's melting because of all the pressure and the warmth of the land, but it's refreezing because it's still attached to ice. So that's the closer it gets, it's melting and refreezing, picking things up and sliding along. So if it's a big rock that's going to be picked up and plucked and running along the land, it's going to make a scrape, and we call that a striation. You can see scratches in rock from where glaciers have run over them. If it's sand or tiny bits of rock that are in here, it does something else. It's called polishing. It makes a nice smooth rock surface. So what I've got here, I've got a warm baking sheet covered with a little bit of ash, and we're going to put our glacier on it to see how it moves as it slowly melts. While we're waiting for our glacier to melt, let's talk a little bit about weathering and erosion. Weathering is the breakdown of rock. Weathering can happen one of two ways. You can either have chemical weathering or mechanical weathering. Chemical weathering is where there are chemicals that are actually breaking down the rock. Now, this could be in the form of like iron and oxygen reacting, forming rust, and that's making a new chemical composition that is going to break apart the rock. You can also have acid rain, water coming out of the sky. If there's a lot of carbon dioxide in the atmosphere, then that water attaches to the carbon dioxide and makes carbonic acid. When that rains on certain structures, that dissolves them and it breaks them down. Mechanical weathering is the process of physically moving something and scraping something and brushing something aside or breaking something open. When our glacier is sliding down the mountain and it's got those plucked rocks that it's scraping along the mountainside, that is mechanical weathering because it's digging grooves in there and it's breaking up the rocks that it's running across into smaller and smaller granules. Water that is falling down on a mountainside, whether it's from just the rain or wind-blown water or a river that's rushing against the side, those are things that are also mechanical weathering. Wind-blown sand is mechanical weathering. Another big one is called ice wedging. This is mechanical weathering when water seeps into the cracks of rocks and it splits them open as it freezes. So liquid water actually gets a larger volume when it freezes. It turns into a larger volume. So we're going to take a look Now what happened to the jar that I put into the freezer last night, something happened because there's water outside. There you can see the water, as it expanded, it had the power to break the glass of this jar into tiny little fractures. I won't be using this jar again, but the power of water to mechanically weather something with ice wedging by breaking it open by the power of freezing. There's a piece of glass